clicked on go live. So whatever you stream now from OBS is streaming to YouTube.
Okay. Yeah. Good morning to everyone. On behalf of the Universidad de Las Américas and Ensure 6G Consortium, it is a great pleasure to welcome to the second day of our training module titled Advanced Wireless Network Security and Privacy, part of the Horizon Europe Marie Curie Staff Exchange Project Ensure 6G. The Ensure 6G project is a multidisciplinary expertise from 15 institutions across Europe, Asia, and Latin America. Through collaboration between academic and industrial partners, the project focuses on developing innovative, trustworthy, and human-centric security and privacy solutions for future 6G networks. Focusing on a driving solution, robust network infrastructure, quantum encryption, ethical frameworks, sustainable business model, and sector-specific insight. The consortium adopts a holistic approach to creating secure, resilient, and innovative 6G ecosystem. Good morning again, and welcome to the second day for our training module, Advanced Wireless Network Security and Privacy. We are excited to continue this important conversation after giving some introduction about the project. On Tuesday, we had the pleasure of hearing from Professor Anne Bracken, who introduced us to the fundamental mechanism of security in 5G and 6G network. Her talk provides a solid foundation by highlighting the evolving threat landscape, the role of cryptography methods, and the importance of integrated resilient security framework as we move toward hyper-connected. Also talk about the AI-enabled systems. Yeah. Today, we will take this discussion further for exploring more advanced and interdisciplinary perspectives. We will address key challenges in AI-driven threat detection, ethical concern, federated learning for privacy preservation, regulatory frameworks, and IoT-specific security in 6G environments. These are critical topics to not only for technical design, but also for shaping trustworthy and sustainable digital infrastructure for the future. Let's start. We will start with the Professor Shen Wang in the University College Dublin. We will have the speaker with the Federated Learning for Privacy Preserving 6G IE system. For the professor, Dr. Shen Wang is assistant professor and academic director of NETS Lab Research Group, a School of Computer Science, University College Dublin, Ireland. He is a senior member of IEEE and an active member of its Intelligence Transport System ITS Society. He received a master's degree from Wuhan University, China, and PhD degree from Dublin City University, Ireland. Dr. Wang has been involved with several Europe projects as a COPI, WP, and task leader in big data streaming for air traffic control and trustworthy AI for intelligent cybersecurity systems. Some key industry partners of his applied research project are IBM Research Brazil, Bain Research and Technology Europe, Telefonica Research, and Fraunhofer Focus. His research interests include connected autonomous vehicles, explainable artificial intelligence, and security and privacy for mobile networks. Welcome, Dr. Shen, and you can start with your presentation. Thank you very much to be here with us today.
Thank you, Paula, for introducing me to everyone. Good morning or good afternoon, everyone, depends on where you are. So I'm trying to share my screen, and please let me know if my sharing is working. So yeah, I hope you can see my slides in the right mode, or in a presenter mode, or is in a...
It's correct, Chad. It's
okay. Yeah, it's okay.
It's the correct one, right? Great, thank you. Okay, so yeah, my talk today will be about federated learning for privacy-preserving 6G AI systems. So, firstly, let's take a look at the basic concept of federated learning. So, federated learning is a type of distributed machine learning. So, what the distributed machine learning is doing is they basically have these kind of data owners placed all across different locations, and but they all very well connected to the training infrastructure. So even the data distributed data owners, they own the data and host the data in the superpower machine, and these superpower machines are connected with the high-speed fiber or other connection materials that is not via the public internet. So because previously, although it's called centralized learning, but all this kind of data and also these distributed machines are owned by one giant entity. For example, Microsoft or Amazon, they have their own machines everywhere, but they are the single owner of the data. They are the single owner of the training infrastructure. So they can do this thing in this way, right? They start asking the data from wherever this data is generated and collected and then sent to the training infrastructure and then train their model. Okay, so that's the traditional distributed, or you can also call it centralized learning because everything is owned by the single entity. And why it motivates the emergence of so-called federated learning is because once we're trying to push this data owner to the edge, to the end user, where this device and also where the data is originally collected is not owned by the single entity, then if we still continue to keep this paradigm working, then we are facing a very serious data privacy issue because wherever this data is originated from, then it has to communicate not through your proprietary communication infrastructure. It will be through the public internet, and we're facing the high risk of getting your personal data lost or hacked by the third party. So, is there any computations system or schema that can avoid this thing happen? Then this motivates the invention of federated learning, so that where the data is originated or generated, the data can always stay untouched or unmoved. Then using this new distributed machine learning training scheme, we call it federated learning. The data stays where collected, and between the data owner and the aggregation server, the things transmitted are only model updates. Because as we all know that machine learning done the same thing iteratively, one round after another. Basically, sometimes may need hundreds of rounds, sometimes may need thousands or even millions of rounds, depends on how difficult your task is. So because the data itself will never appear on the or exposed to the public internet, thus this is very promising for the future digital era where the personal data's privacy is of uttermost, especially when the data owner is a mobile end user where you take a lot of your personal live photo, or the organizations such as the bank and hospital where these personal data, when it's collected, and it has to stay away from the digital world. Okay, so how it is getting trained. So this algorithm called FATF, Federated Average, is full name. So this is one of the most commonly used federated learning training paradigm. So basically, let's say on the first step of FedF is from the server. So firstly, the first step is central server choose a statistical model to be trained. So normally when we are referring to the machine learning model, it is the classifier. So this refers to the classifier decision boundary. Okay, the second step is this server sends this model, the same model, to all the worker machine or the client. As you can see that everyone has the same copy of the same model. Well, what's different is this step 3, each one of the client has different portions of their data. So they all have collected their own data. That is why normally their data distribution is a bit different. So and then step 3, the main task of step 3 is they all do the training locally in parallel. Therefore, compared to step 3, you will not see any communications happen, right? There is no communication happen between server and clients, even among clients. And because their data are different, therefore, after training, the classifier on each client side is different. So each client have their own different models. While to proceed to step 4, then each one of the clients still have their own different models, but they need to use the communication infrastructure again to send everything up to the aggregation server. And then the aggregation server have each one of their copy and then make the average. And then that's the agreed or aggregated global model for the next iteration step. So that is called federated average. What is transmitted in between server and clients is always model updates, right? So everything seems great because the data will never move until we find mathematically that it is probably not the case. Here we take a relatively easier problem, right? So let's see, we are training a regression model, and the loss function is the least square. Okay, so we're trying to minimize this loss function, where this loss function equals to this least square function. So we're trying to minimize that. And then remember, normally, according to the mathematical notation, this xi is the data and yi is the label of the data. So when we take the derivative of this loss function, we find that this is a gradient and this is the updated model one round after another, right? So this data is just a kind of transformation of these. Okay, so the transformation of the data itself, will be leading directly to the model update, to the gradient, and the gradient will be a kind of linear transformation back to the model update. So which means that although this transformation is non-linear from the data directly to the gradient, but the transformation is actually very clearly defined here. So it is actually theoretically possible that once you get not the data, but the model updates iteration by iteration, you will normally know how to reconstruct the real data that you thought is never being transmitted over the public internet, but accordingly you will find a way to reconstruct it. So which means privacy risks are still there, although it's not that straightforward, but it's still there, how to protect it. And there are a few more challenges when we are deploying federated learning in 6G era. So traditionally, in 6G or non-6G era, federated learning challenges, there's always about communication overhead. So the communication overhead, why is that the issue? Is because, look, again, these gradients or the local updates share the same dimension of the data. So although you are not transforming the data, but they're sharing the same dimension of the data. So which means that the model updates that you're transmitting is not small. And what's more important in 6G era, 6G guarantees the high bandwidth, low latency again. So which means hopefully this communication overhead issue will be mitigated. However, these massive connections and this, trying to connect everywhere promise will bring up this heterogeneity issue to the more challenging level. So the data heterogeneity means, this different type of labeled data will be different across different machines, and also the quantity, So the type of the data and the quantity of the data distribution, the heterogeneity level is very high. How to deal with that? And also the device. Some device could be the smartphone, outdated smartphone. Some device could still be a mini-scale superpower machine. So, which means that after the single local training round, some device can finish the a single training very quickly than the other slow device. But they all have to wait for the slowest device to finish the single round, the current round of iteration, and then submit to the central server together. If not, then we can go to a synchronous federated learning. But because 6G trying to connect all types of devices, this gap will be huge. So how to make the trade-off is another challenge. Okay, so I think I have covered all the basics of the, what is federated learning, why federated learning is more challenging in 6G. Hello? Yeah. Now let's have a quick look at I think someone of us, yeah, okay, great.
Sorry.
Yeah, no problem. So I will quickly go through series of federated learning works that has been done in our NET lab in recent years. Okay, so firstly, the work that I want to introduce is called RecDef. So as you can see that federated learning, these model updates transmission happened over time, right? But before this work, we haven't seen any data reconstruction attack is actually focusing on these time series things. So over the whole training round. So we firstly study this type of attack in the use case of VR based IoT consumer scenario, and then we demonstrate how risky it is to use this data reconstruction attack on that. And also we propose a new recommendation framework for privacy update. So sometimes when you try noise to the updates, then you find your model is not working. So too much noise can preserve your private data, but it can deteriorate your model performance. So as you can see here, those are highlighted results. If we add no noise, you can see after several iterations, these ground truth data will be successfully reconstructed. But while we are trying to increase this noise, even up to 10%, this data reconstruction attack will not work. And also compared to other framework, our methodology will not impact this model performance across the time. So, which again demonstrate the effectiveness of our method from other angle. Right. So that's the first work. The second work I would like to share with you is called Shield. So this is published by in a top journal in security and privacy domain. This work basically focusing on a new federated learning paradigm called hierarchical federated learning, which means the system architecture we're focusing on is not just about 2 layers from server to the end user. It is focusing on more, including more middle layers, which will be more popularly seen in 6G era, because in 6G era we will see a lot of connections, and if the central server needs to handle all these connections, they will create a lot burden to the central aggregation server to handle. Therefore, we introduce 1 layer or more than 1 layer in between. So this work is not only focusing on 3-layer hierarchical federated learning, focus on whatever layers that you would like to introduce in between. So it is quite general. And also, this work is demonstrated on different types of heterogeneous network. Depends on where these poisoner users are from, and also depends on where this data is distributed. So we introduced this alpha from data clay distribution. So the smaller the alpha is, the more diverse the data distribution is. And so basically the shard works in a way like, okay, so we still follow the traditional way where the central server send the global model first, and then each client, including the poisoned, compromised clients, training their model locally, and then once they send their update for the first to the first layer, then the first layer machine start to use HTTP scan to find and remove the outliers. And up until the central server holds the global model for the previous round, and up to the central server will be checking this distance-based calculation rather than running the HTTP scan for all the middle layers for model aggregation. So we have tested this methodology very comprehensively and against the state-of-the-art solution, and we have this recommended use of our shelled method in a full spectrum. Depends on the percentage of the poisoned users, and also depends on how your data set is distributed. Okay, so that's the second work, shelled focus on hierarchical federated learning. The third work that I would like to share with you today is called SHEPRA. So the key highlight of this work is to use explainable AI and trying to get these justifications for the machine learning model to make their decision. And then using these justifications, by using these justifications, we can try to fill up the existing gaps for the work, for the SOTA work. So we can see that there are 2 types of the SOTA work. The first type is history-based repetition scores. For example, full scope. The downside of that is if the new client is added. Imagine that in a large scale of distributed federated learning training network, you cannot guarantee that always these users are not changed. So in practice, the users leaves joins and leaves from time to time. So if a new client is added, then we have no prior history of it. So then it makes full Scope hard to run, and also including full Scope, Chrome and Flame, they are using similarity based metrics, which means that if the majority of the clients is malicious, then this method is hard to work. So what we are doing is we for the specific machine learning task, we have a highly trustworthy small sample, and then we identify the behavior of the machine learning model, and we extract the so-called correct justification, and then we deployed it on the aggregator side, and then the aggregator side would have the not just about these client updates, but also the justification on how AI decision is making, how the correct AI decision is making. So then it is actually quite good that to show that it is effective across all the poisoned clients. So compared to the previous one, Shout, the percentage of poisoned users, when it goes large, it is still not very good to handle it. However, Shapra is quite good in full spectrum of the percentage of compromised clients. So the last but not least is the work that I would like to share with you. Is the peer-to-peer fallacy learning. So it's a full distributed fallacy learning network. So this is the initial work. We are open for more collaborations so far. So we so this one is like we don't rely on the central server anymore, since fallacy learning is a type of distributed machine learning. So why not make it more distributed? Let's try the fully distributed one, so that each one of the node will have to engage in the training process, and also will have to engage with this model aggregation process. So then how to ensure its efficiency, and also how to ensure the privacy and security on the quite dynamic and sensitive network topology is kind of challenging things we need to face. So yeah, basically, this is more like a peer-to-peer fallacy learning implementation, and we are playing around the parameters about network topology. And interestingly, we find that that peer-to-peer fallacy learning actually converges very quickly compared to the centralized or traditional fallacy learning paradigm. So we also find that if you are allowing exchange of the model update from 2 of your neighbors rather than 5, 2 actually converges even faster. The smaller number of neighbors you're communicating with, the faster it gets converged. Which also is an interesting finding, because we can see that when we are considering the fully distributed network, you cannot assume everyone is fully connected. Otherwise, the whole network complexity will be very, very high. And we see that with and without differential privacy, which is basically adding more noise to make the model updates more secure, has no impact on this model accuracy. The final converged model accuracy still remains. Of course, this work needs to be tested more under more extreme scenarios, but this is the initial work that I would like to share with all of you. Okay, so that's everything I want to say today. Hope you enjoyed it, and I'm happy for any questions that you have for my talk, and also this series of federated learning related work from UCD NetLab. Thank you.
Thank you very much, Dr. Shen. Here, there is there are some questions, please. How does the federated learning enhance privacy compared to the traditional machine learning approach?
Yeah, so to the traditional machine learning approach, this all backs to the very beginning, right? So the data stays, the traditional machine learning data always stay physically in the machine, while federated learning, the traditional machine learning, the data stays here, and also while we're training the model, the data moving over the wire, over the connection, over the public internet, whatever, over this communication wire or wireless channels. So which means that it is exposed for the attacker to launch any kind of attack. So any kind of attack that is successfully launched, they will get the data directly from this training period. While federated learning has this data physically stayed while you are training machine learning model, it is still unmoved here. Although I said, later, we are still facing the privacy leakage risks, but model updates, you still need to accumulate the model updates over the time. You still need to launch a sophisticated, customized or specifically designed data reconstruction model to do that. So it is still like, attacker needs to cost something. So that is why federated learning is still a good one to preserve the data owner's privacy compared to the traditional machine learning paradigm. Okay.
Yeah, sure. Thank you very much. Here is another question. What are the biggest technical barriers in implementing federated learning in real-world 6G systems?
Yeah, so I think, according to my knowledge, this is all about the scale and also all about this data owner. So the federated learning is not largely deployed. It's because when we largely deploy federated learning, there are a lot of different types of data owners. And each data owners needs to know that, okay, their privacy is preserved physically, but they also need to be aware that what are potential risks of using your data. And, so your data will be used, but your data will be staying. So, it's hard to explain it to the end user that, okay, this data, will be always stay in your machine, but will be kind of used by us. So, and the more data owner, the larger the scale is, the more challenge that you will be facing by this heterogeneity challenges, right? So you will definitely need to go for asynchronous federated learning in order to make your training process uninterrupted or smoothly finished. But if you are federated learning up to the very large scale, then it's very hard to predict this gap. So when the gap gets bigger, then there are a lot of unexpected things happen, and then you need to spend a lot of time of your engineers to tune it. So far, the successful deployment of federated learning is not for the big scale, but so far in a kind of sandbox or enclosed scenario, it is working very good. I've heard some successful cases in bank and also hospital. So the these data owners are all hospitals, but different hospitals, which means these fast learning clients are not so much. But because smart health, we need different hospitals to exchange the data, but they don't want. But okay, you don't need to exchange the data, but you can share the access of your data while we're training the model. The model can be shared. The model is not trained by your data only; it's trained by everybody's data. So then this one works great, and also this one was great. But all these two successful cases does not have a lot of data owners. That only about 10 or 20 something. Okay, yeah. Hopefully it answers your question.
Yeah, surely it was very clear. Thank you so much. I don't know if someone want to add something else. Yeah. Thank you very much, Dr. Shen. It was very pleasure that you give us and share with us your work, and so good. And now we will share with another professor. That is the Professor Basak Ozan Osparlak. Yeah, it's the University Oxygen University, Turkey. Is here. Hi, Basak.
Hi, Paula. Hi, everyone.
Hi. Now I will introduce to her. She will talk about the regulatory frameworks for responsible AI in global 6G development. Dr. Basak Ozan is an assistant professor at Oxygen University Faculty of Law in IT Law. She earned her bachelor degree from Marmara University Faculty of Law, followed by Master in Union Europe Law and PhD in private law from the same university. Science 2016. Dr. Osparlak has been active in both industry and academia, focusing on the legal and regulatory aspects of emerging technologies, such as AI, human-robot interaction, and legal aspects of the next-gen 5G, 6G wireless technologies. Her research interests include data protection and privacy, AI and law, cybersecurity law, 5G, 6G, privacy and security. In 2023, she joined Oxygen University as a full-time faculty member, where she continues to contribute to the field through research, teaching, and participation in international projects. She received Oxygen University Excellence in Research Award in June 2025. Congratulations. She has listed as one of the 100 women in 6G in 2025 list. Welcome, Professor Basak. And his presentation is Regulatory Frameworks for Responsible AI in Global 6G Development. Welcome, Basak.
Thank you so much, Paula, for organizing and presenting this conference, this event. And can you see my screen, full screen?
Yeah, we can see, but no full share. It's just the slides.
Okay, maybe I can share the PDF version. Let me do it. And by the way, let me thank you again and all the Ensure partners and everyone here with us today. And with Ensure 6G under working group 3 with Galit and Brecken, we are tackling with the regulatory and ethical aspects of 6G and secure and private 6G. Let me try again. I'm sorry. All my screens are open actually, but if I cannot, I can go on without slide also and share the slides with you later. I don't want
Yeah, but you can share. I don't know if you convert to PDF, maybe.
Yes, I have PDF
Okay.
also.
Okay.
Let me try once more.
Okay. Let's try.
Okay.
Then if you go for a full screen, is there in like that icon down right? Is like a cup next to the Zoom.
Yeah, I pushed it, but it did not.
But it's not.
Yeah, can you see my screen?
See, I can see your screen, but it's completely screen with a PowerPoint. But it's no just a slide.
I think it's well visible actually. So if you want to,
it's okay.
keep that, there's no issues.
Okay,
I think it's almost full screen, so we are happy with that.
Thank you. And it's so hot in Istanbul here. And hello everyone again. And my presentation will be about regulatory frameworks for responsible AI for global deployments of 6G. First of all, let me begin with what do we mean when we say responsible AI? Actually, we're not supposed to say, and we don't mean here that we will give some confer rights and liabilities or responsibilities to AI systems itself, but we are here underlining the fact that since AI to be trustworthy, we have to govern it in a responsible way. And it is so crucial for 6G deployment in a global sense because 6G, as also Shan underlined, the fact that will be an AI-enabled network. And in International Telecommunications Union report in about IMT 2030, they also underscored that AI is at the core of the future communication system, and there will be continuous, always, and ubiquitous data processing all the time, and that will be mostly by AI itself. And also there will be some, as again Shan underlined, that there will be some heterogeneous devices and data sources. So it will be so hard if we cannot tackle these responsible AI questions and challenges from now on. So as we all know that if we begin with the EU legal framework, there are a plethora of regulations and legislative frameworks and some others upcoming. And so, but of course, when we are talking about AI, the first thing comes to our mind in the legislative sense is the EU's AI Act, which is the most comprehensive act in the global text, and this is the first one that covers AI in so many ways. But before that, we have to check what do we mean again by responsible AI. And legislative frameworks actually without some fundamental ethical foundations, they are like empty hardwares. If we cannot embed them, if we cannot find some fundamentals, ethical fundamentals, they will not give us their aim. They will not that much effective. So we have to first put an ethical framework, ethical baseline before taking one more step and to go through creating a brand new legislative framework. So the EU regulator followed this way, and in 2019, an ethical guidelines for trustworthy AI has been shared with the public, and it has been created by some independent experts by the European Commission, and there are some 6 or 7 fundamentals, ethical fundamentals for trustworthy AI, which are also important for responsible governance of AI systems and models. And these ethical framework, which involves 7 ethical principles, will followed by some other international and national bodies when they are creating their own ethical framework. For example, OECD, we will check later on, and some other
I'm sorry,
national...
Başak, can I just check with you? Are you flipping through slides because we're still
No.
on the first one?
No,
Oh,
yeah,
okay, okay. Sorry,
yes,
I thought
my
you were
talk.
already on the second one. Sorry for
didn't
jumping
write
in.
I didn't want to write many things, but thank you so
Okay.
much. Okay, and these ethical principles, some of them are human oversight, robustness, which covers cybersecurity as well, and privacy, respect to privacy and data governance, transparency, human oversight, accountability, and diversity, and non-discrimination and fairness. So these are fundamentals in order for us to steer an AI as in a responsible way. But again, we have to say that who are going to responsible from the harms that AI can pose? All the bodies and all the deployers and providers, and also the national or international bodies, not the AI systems, of course, themselves. So when we check the EU's digital framework, actually coming from the AI Act, GDPR for data protection, Data Governance Act, how we can share data between institutions to give some services. For example, if we are to creating an AI service, AI system, or a product for in health sector, we have to get some data from health domain. So how can we do this with respect to GDPR at the same time? So Data Governance Act covers this framework. When we come to Data Act is also important for 6G because it covers the data flow, both personal and non-personal, within the Internet of Things ecosystem. And when we come to the Digital Market Acts, they also tries to limit the powers of big monopolies. They try to limit the monopolistic structures in the digital market also, including AI. And Digital Services Act here also, if we are to make AI, if we are to use and develop AI in a responsible way, we have to ensure that it is within alliance with cybersecurity regulatory framework also. And when we look at the EU's regulatory framework, in this sense, the first and one of the most important regulatory framework is NIS2 directive. And it is actually an evolution from the first one of this. But this one, NIS2 directive, covers also and is adopted in 2022, by the way, and is applicable in 2024. And it anymore covers some technological breakthroughs and connectivity needs and capacities like 5G and beyond. And it is for improved security with digital aspects. And Cyber Resilience Act also so important because it is also enforced since December 2024, and it will be fully enforced by 2027, 3 years before the global deployment plans, at least, of 6G in 2030. So what does Cyber Resilience Act bring here? It promotes core fundamental standards for cybersecurity, beginning from the design phase. It is so important. And it involves all the products with digital elements, including AI embedded software. And again, in the sense of cybersecurity, of course, we have, which was published in 2020, the Cybersecurity Act, which involves the cybersecurity certificate framework. And it will be much more important during 6G global deployment because maybe in this soon or in the long term, in some critical infrastructures or in some critical sectors, some products or services will require high-level cyber resilience, cybersecurity certificate to be enabled to enter into market. And ENISA in 2020 published 5G related threat report actually, but it didn't involve yet some societal or legal threat. But from now on, we know that, and as Ensure 6G project also focuses also one side here, and social and legal risk also important for technical aspects also, in the sense of compliance and in the sense of responsible AI deployment. And also technical side is vital for legal scholars, because we cannot understand the technical side, but for example, in order to have some checklists and risk assessments, we need technical domains side. So it is very important to bring some interdisciplinary works together, like it is in Ensure 6G for responsible AI before deployment of the 6G in global sense. And if we are to look at AI Act more closely, maybe you all know that it follows a risk-based approach, and it has a general scope. What do I mean by that? It's like the GDPR scope, actually. Even if you are some non-member EU country and you are planning to put your product into market or put your service into the market, and if your product or service is embedded by AI or is to just a software, AI software, you have to follow and you have to be in compliance with EU AI Act rules and mechanisms. So it is a general application scope. It is much more important than, it's not just about the EU's regulatory boundaries. And the main aim actually in the AI Act is not to protect fundamental rights and freedoms. The main aim is to improve.
Sorry to jump in again, but the slides are not changing at all.
Yeah.
So we are still on this first slide, and I think we should be on slide 5, right?
Yes. Yeah.
So maybe you are sharing the wrong screen. Do you have 2 screens?
No, one screen, but it happened to me.
Now it's perfect. So now we're on slide 4.
Okay, I'm not in the full screen for me also. Okay, you can see now?
Sorry,
yes, we on slide 5 now. Yes.
Is it changing?
Now it's changing, yes.
Okay, thank you so much.
Okay, fantastic.
Thanks. Yes, for example, EU's AI Act is not focused on protecting fundamental rights and freedoms. It wants to serve for the European market's resilience, but it is vital and it depends on fundamental rights and freedoms of EU Charter, and as well as the ethical framework, ethical guidelines for trustworthy AI that has been established in 2019 by Expert Committee of the European Union. And here, before getting to the transparency, I would like to underline one fact also. We know that GDPR is the main regulatory tool for the European Union in order to protect data protection and provide privacy also. On the other hand, now we have the AI Act, but although they are separate regulatory framework, they are separate regulations, we know that from the recital, from the blatant and explicit wording of the AI Act, that they're not excluding each other. For example, in Recital 9, the AI Act explicitly says that this act, the AI Act, is complementary to the GDPR when it comes to data processing by AI. So the GDPR is still fundamental for data protection and ensuring privacy for the data processing which is being done by AI systems or models. And AI Act also vital for market and also for depending on the fundamental rights and freedoms. So they are hand in hand, we can say. NIS2, I had referred before, but NIS2 covers all the telecommunications sector, and it's too important for 6G global deployment also. Security by design and by default, for example, end-to-end encryption comes with it. And due diligence for assessing whether your suppliers are in compliance with this framework also is important. So here again, I underline the necessary cooperation between technical domain and legal domain. And there have to be a risk management for covered entities And there are also 10 minimum measures like legality by design, including also technical size, for example, cryptography, training, etc. And also there is Radio Equipment Directive, and Radio Equipment Directive is also linked with deployment of 6G, and it involves some provisions for radio equipment, and ensure that personal data and privacy of the user are protected. And here comes also, again, the Cybersecurity Act. I mentioned it's one of the most important aspects, as it will bring us some cybersecurity certification scheme soon. It is vital for 6G to be reliable and trustworthy and responsible, used in a responsible way, so that we can show that if we are preferring a product or a service as a deployer or as a user, for individual users or for commercial users, we can see easily and we can detect easily which product or service involving AI is much more resilient. And so maybe we can prefer this one thanks to the cybersecurity certification when it comes to life. Also, there is another regulatory framework in the sense of EU's regulatory framework. A new product liability directive is very important because unlike the other one, unlike the precedent one, software and AI is now included to the product liability directive. And it is also indirectly linked with 6G. Why? Because there are some tips here. For example, if you are a non-technical user for a system, for a product, which involves AI, for example, and you think that you are as a person, you get harmed because of this product's deficit, but you cannot prove it because it is too technical, and you're a non-technical person. Even you're a technical person, maybe you cannot put forward some proofs in order to prove fault or causation between the deficit and the harm. So the regulator here brings us that if there is a technological complexity, and which will be assessed in case-by-case situations by the judge, and if there's a complex structure of the product, for example, as innovative medical device, you can assume it, for example, a brain-machine interface device that will be deployed in 6G. Or the nature of the technology itself, it could be complex. For example, machine learning, they say. But we can also say that large language models, like generative AIs, which will be also embedded and will be used in the 6G. And also the complexity of information, they say, that will bring this presumption of defectiveness thing. And also, when we say, as Shen again underlined, that there will be heterogeneous data flow, devices, lots of devices, lots of types of devices, lots of types of data sources will come together in a high rate. So this presumption of defectiveness will be much more discussed in later on, I assume. Yes, EU regulator followed a way that before creating a special AI regulatory framework like the AI Act, and the first version of the AI Act, and it was published, shared with the public in 2021 before it entered into force. And you know, it entered into force last year. So before that, they established a general ethical framework for trustworthy AI. And these trustworthy AI principles are followed by international bodies, as I said. And one of these international bodies is OECD. OECD also had published its ethical principles for AI in 2019, but they updated it last year in 2024, and it involved two sections, and two of them also directly linked with the responsible usage of AI for global deployment of 6G. And the title of the first section is principles for responsible stewardship of trustworthy AI, which is totally and 100% correct title, because as we said, AI cannot be responsible itself. We are responsible to steer it in a responsible way for it to be trustworthy. And here they said there must be, these are the principles for that: inclusive growth, sustainable development, and well-being. The notions that trustworthy AI should serve, they say. And it's, of course, respect for the rule of law, human rights, and democratic values. And transparency, we can see it here also, and explainability. And in the sense of cybersecurity, they say robustness, security, and safety must come first, and accountability. And secondly, it is important for global deployment of 6G, there must be full alignment between national jurisdictions, because there are lots of different jurisdictions between countries. Their judicial system sometimes are so much different from each other. So how can we manage to cooperate with each other because 6G will bring us a global data framework, and it has to be there has to be a global consensus. How do we manage a cooperation between jurisdictions? It is hard, but we have to do it. And they also underline the fact that investing in AI research and development, here they also underline the fact that for AI to be trustworthy and for us to govern it in a responsible way, we have to invest in open source AI studies. Also, we have to foster inclusive AI enabling system, leaving no one behind. And also, at the last, international cooperation for trustworthy AI is a must. And they, of course, they didn't mention 6G, but we all together know that the last one is very crucial for the global deployment of 6G. And among all the principles for ethical framework of AI in the global sense, both in the EU, in the OECDs, or in UNESCO's some declarations, on some national AI strategies, we can see nearly the same principles. Sometimes they come under different titles, different wordings, but we see one of them always there with the same wording: transparency. Transparency may be one of the most important ethical aspects for responsible steering of AI and trustworthy AI, because in order to understand and check or assess whether AI system or AI model is in full alignment with other ethical principles, or it is incompatible and is compliant with regulations, we have to know first if we are interacting with an AI system or not, or a human being, and then we can make our checks and balances after that. So transparency here, we can say that has a priority among all the principles for AI to be trustworthy. But transparency for whom we are talking about, of course, but again, first of all, we cannot ensure 100% transparency, of course, because there are some technical limits on the other hand, and on the other hand, there are some technical, for example, secrets, intellectual property rights. We cannot provide technical and legally, for example, in the sense of privacy also, we cannot have 100% transparency, but we need enough transparency. Whether we are contacting or communicating with an AI model, it will be much more hard in the age of 6G, since all the human beings also will be an integral part of 6G network as body-on sensors. There will be also AI agents, and human-to-machine, machine-to-machine interaction will be much more than of today. So transparency, therefore, will be much more important in order to ensure a reliable, responsible, and trustworthy AI. And humans in general have to know if they are interacting with an AI system. And for affected persons also, it is much more important. For example, in a provision in the GDPR, General Data Protection Regulation of the EU, In Article 22, if you are a person and your data is processed solely by automatical systems, then you have right under some circumstances to demand an human intervention, for example. But in order to use this right, for example, it's just one example. First, you have to know if you're interacting with a fully automated system, such AI, for example, or not. And thirdly, transparency for developers. Maybe some developer, for example, a hospital cannot create its own AI system. Maybe they will go through some vendors, but which vendor they will prefer. Again, here, transparency for deployers is also important, enough transparency, of course. And since we are talking about global domain, it is important that, and by the way, please warn me if I lose my time. In the global sense, regulating AI is not an easy task, of course, because there are some debates. For example, always we are hearing that AI is very complex. You cannot regulate AI, or if you regulate AI, you will hinder innovation. But it's not like that always. It depends on the regulation itself sometimes, because AI, on the other hand, plays a strategic key. It has a strategic role, and no one wants to lose their competence here. So, for example, in the US nowadays, there is a debate going on. It's a very important debate, and its result will impact, for example, everywhere. We say Brussels effect when we talk about EU's legislative framework, but maybe we will see Washington effect or not, we don't know. The debate is that, as you might heard of the Big Beautiful Bill by Trump, and it's a budgetary bill actually, but it has some other kind of provisions. For example, they are planning to limit the state's regulatory power on limiting AI systems for 10 years. For example, as a state, for example, New York, you can take New York. New York has just, for example, accepted in its Senate as AI security bill. If this Big Beautiful Bill accepted as it is right now, and New York State's bill will be void. So these regulatory frameworks, even if they are about security, there is a risk that it can be banned in the both federal and state level for 10 years. Of course, this is about the United States, but it will have also impacts for the world in general. So why to regulate? Why are we trying to regulate AI? Do we have to regulate AI really? Yes, innovation is important, but even for the innovation itself, even for example, a fair market conditions for every innovator, we have to put some objective rules for everyone, beginning from, of course, security and privacy, so that AI will serve not only a bunch of people or companies, but serve all the world, and we can use it, by the way, responsible way. And in Latin, there is a phrase that qui custodies ipso custodies, who will guard the guardians. So we have to put some mechanisms also for the detectors of the AI systems and the models also. And the near future issues, what will be regulating, and in the sense of 6G, for example, since we will integrate NTNs, non-terrestrial networks, with terrestrial networks, there will be, and actually from today, there is a need for a spectrum regulatory innovation today. So how can we merge this NTNs, and how can we give regulatory licenses, spectrum licenses, under which conditions? How can we assess their cybersecurity? So in also Hexa X2 deliverables also underlines the importance of regulatory initiative here. And since in the space domain also with the satellites, the space data will be also processed by the AI systems, these are also fundamental questions and challenges for in the sense of regulatory field also. And also yesterday, an important thing happened in the EU. EU has just published the first proposal for the Space Act. And in the Space Act, it involves the cybersecurity aspects of space elements like satellites, and which will be very important for 6G global deployment also. And we will have to find a way and how do we merge regulatory initiatives. How can we align our jurisdictions? How can we give spectrum licenses? And how can we ensure the cybersecurity and privacy of space data before global deployment of 6G? And one more near future regulatory action is on the way in the Q4 of this year. Digital Networks Act will be on the scene. And this is also important for 6G, and it will involve a deadline for copper networks by 2030, which is the year of the deployment of 6G. And it will try to balance the EU's and the member states' national interest on the sense of spectrum. And it will involve some major cybersecurity provisions on 5G and 6G. So when we say that AI is an enabling 6G is an AI-enabled network, these regulatory frameworks, which along the AI Act and Data Protection Act in the EU, also will be important for the 6G's global deployment and also the usage of the AI in a responsible way for ensuring security, because security also is an element, core element, one of the core elements for responsible AI usage. Thank you very much. You can contact me here. Gracias. Teşekkürler.
Thank you so much, Basak. We have some questions, but if you put your contact there, maybe the people can contact you. I will ask you just one question, yeah, because we have several. What aspects should be prioritized when creating a responsible regulatory framework for IE in 6G?
Which one is the most important, Demi?
Yeah, what aspects should be prioritized? How you put the priority there when you create a responsibility?
Yes, it's a beautiful question. Thank you. Actually, since AI based on the data itself, any regulatory framework touching the privacy and security of data is vital. So as the European Union's AI Act says that the AI Act is a complementary to the GDPR when it comes to data processing by AI, data protection regulation and cybersecurity frameworks, in my opinion, are much more important than the others.
Okay, thank you, Professor Basak. It's very important your presentation, because now we need to know about everything, because everyone is talking about the regulation, how the AI we need to use everything. We have something, Mariela Medina, maybe some questions. Mariela. A ver, Mariela, just let me. No, it's not saying anything. Let me see them.
Bart is raising hand, I guess.
Yes, since Mariela is fixing her, I guess, technical problems, I have a comment. Yeah, I have a comment and a question. I was very happy to see this familiar quote, "Who will guide the guardians?" Because I was thinking about this at some stage we had a problem with like the police. So who's policing the police, right? And there are structures in a country that can do this. So it reminds me of a case in Poland where the police have purchased a invigilatory software that was, of course, used not only for invigilation of potential crime, but also the invigilation of politicians and the others. But leaving that aside, this is just my comment. This is very important that you need to police the police and you need to guard the guardians and who is doing this. The question is, you are operating in Turkey, so you will be familiar with what's happening in your country, but I guess similar things are happening in other countries. So when GDPR came out and it became a thing, and let me maybe show my camera. Hi. When GDPR became a thing, everyone panicked. So nobody really know what's going on, how to implement this, what are the implications. Everyone was afraid of the fines, except maybe the big companies that were untouched for the first beginning of the GDPR. The AI Act is sort of a successor. Well, not a successor, but another act that we needed that works in parallel. So do you see anything in Turkey that is happening in the country level? So is there like anything between people and the AI Act that we need on the country level? So do people already know where to complain, for example, if someone is in breach with the AI Act? Because with GDPR, it wasn't so obvious until the country of Poland, for example. In Ireland, it was the same thing. Until the country did very big marketing about this, people didn't even know which department they're supposed to complain. Is it the department of communication? Is it the Department of Human Rights? Is it the local councils? So do you see how like any changes in the country level that are happening to make sure that AI Act is enforced?
Thank you. Yes, in Turkey, we are not a member country, but we are a candidate country. So we have to align our legislation according to the EU's legislative framework, like we did in Labor Act, for example, like we did in Intellectual Property Act. And there is a commission established at the ministry level, and they are planning to make an effort proposal, for example, next year in the AI sense of AI Act. It will be in full alignment with the EU's, I believe. But yes, is there a need? But before that, even we are a candidate country, so because that according to the agreement between us and the EU, we have to align our legislative framework. But secondly, we have very tight commercial relationships. So, for example, especially in medical sector, there are lots of Turkish companies that providing AI embedded services. And they are planning to, for example, enter into the EU market, or already they are in the EU market and they are planning to make some extra product and services with AI and they have to be in alignment again with the EU's AI Act, like each country. And we have a GDPR kind of regulation and personal data protection law of Turkey, and the communication is provided us that we know, even non-legal persons or non-technical persons, we know that now that where to go if we think that our data is processed illegally. For example, we have to go to the data processor first, and then we have to go to the data protection board of our country, and they make some assessment and checks and balances, and they give fines if they say that there's a breach of this act. But of course, in the daily life, no. No. In the daily life, we give always constantly giving consents. And one of the most important things is here, like in the beginning of the industrial revolution, there are machineries came into the factories, and now they could use even child labor with them. They will just pull a thing, for example, and there were some bad consequences in the factories and in the work safety and healthy issues. And then they make some regulatory initiative in the UK. They put forward Factory Act. But according to Factory Act, you have to obey the rules, and these rules only can be complied by big factories. So that bigger ones take the little ones, so it served for monopolies. We have to remember this history also.
Yes, you also reminded me about something that a lot of people forget, that we have to comply with the AI Act, but there's actually specific deadlines for this. So this is what people forget. It's not as lean as GDPR. So, for example, there are some items like I remember biometrics. So if you have some kind of biometrics use in, for example, especially like public settings, then you had to comply with the AI Act. This deadline is already passed. This was like end of 2024. And then you had some like high risk systems, like, I don't know, like data governance logging. And the deadline, and it's next year, August. And they, for different stakeholders and different applications, there are different deadlines. But this is like next year, August more. And I would love to believe that every public, at least, application that is developed and deployed by cities and councils, local governments, complies with this. But I believe this is a wishful wish, especially for smaller countries, smaller cities that don't have this capability even to test everything under the AI Act from the AI Act perspective. So I think people really very often forget about the actual deadlines, and this is, I think, no joke. And I think hopefully, especially the big companies and the governments will adhere to this. But of course, we are talking about EU and that's all the candidate countries and so on. So yeah, thanks for this answer. I think this was very interesting presentation, especially for computer scientists that doesn't know a lot about law. But this is the essence of this project, I think, right? For us to, for you to open eyes of computer scientists, and maybe you can learn something from us.
Thank you so much.
I think this is a perfect example of that collaboration. Okay, thanks a lot, Başak. I appreciate this. Great presentation. Thank you.
Thank you so much.
Very good. Thank you, Başak. Thank you, Bart. We will continue with the next speaker is el Dr. Aaron Echeverria, the Universidad de Las Américas. He is going to talk about security for IoT networks in 6G system. I will introduce quickly him. Aaron David Echeverria received his bachelor degree in Electronics and Information Networks Engineering from the University of the Las Américas and master degree in Cybersecurity Business Administration and the Internet of Things from the International University of La Rioja. He is currently pursuing a PhD degree in Information Technology at the University of Malaga. He has also been assistant professor at the Universidad de Las Américas UDLA since 2024. With over 6 years of professional experience in the field of cybersecurity, his work focuses on the key areas such as hardening of operating system, automation of security process, secure architecture for critical infrastructure, and IoT security. He has authored several peer-reviewed publications addressing this topic, including the development of cybersecurity models for IoT, methodologies for improving system hardening, and hybrid architecture for secure microservice. His research also explores innovative approach for optimizing the development and protection of Linux-based systems in industrial and cloud environments. His interests lie in the interaction of IoT security, industrial control system, cloud-based virtualization, and the implementation of robust cybersecurity frameworks. Please, Dr. Aaron Echeverria, continue with
Thanks,
your
Pau.
presentation.
Pau,
Thank
one
you.
thing.
Sí.
Thank you very much for the presentation, but I don't think I will be able to make the presentation because I have a session scheduled at 11:30. My presentation was
Yeah.
originally planned from 11 to 11:35. I don't
Okay.
think I could give the presentation in 5-10 minutes.
Okay.
If
Maybe
you
if
prefer,
you give some introduction about the topic, and
I could be the more fast possible.
yeah. Okay. Thank you.
So we will be sharing all the presentations maybe in the blog post later. So if you just give like 5-10
Exactly.
minutes abstract of
Exactly.
what it is, and then we can share that. Okay, let's go ahead.
That's nice. Okay. Warm greetings. I'm Aaron Echeverria, and today I will be presenting on security in the IoT ecosystem and next generation networks. And this is for another time. What's IoT? IoT refers to the network of billions of devices connected to the internet, sharing data, service, and processes. IoT applications are found in various areas like smart homes, such as Alexa device, voice assistants, and smart thermostats. Healthcare with medical sensors used to monitor patients in real time. And industrial environments, including robots, sensors, and logistic trackers. And what are next generation networks? 6G refers to the sixth generation of wireless communication technology. It is expected to launch commercially around the year 2030. It's going to be 100 more faster than 5G. And 10 million devices per kilometer, they are going to be with ultra-dense connectivity. But we have a combination, IoT plus 6G. It's a powerful but risky combination. This convergence of IoT and 6G technologies promise to transform how we interact with the digital world. However, this combination also introduces a significant cybersecurity risk that must be addressed proactively, like massive attack surface, network compromise through weak devices, and cascading failures. Here we have main security risk in IoT devices. A limited resource, many IoT devices have very low processing and power and limited memory. This restricts their availability to implement the strong security features such as advanced encryption of real-time threat detection. Another is poor authentication. A common problem in IoT is the use of default or weak passwords that are never changed after the deployment. Many manufacturers ship devices with a preset credential such as admin or 1234. And inadequate protection. IoT devices often transmit sensitive data without encryption, leaving it exposed to intercept or tampering interfaces such as USB, HTTP, Telnet, or open ports that may be left unprotected, which attackers can exploit for remote access or control. The typical attacks against IoT, first, botnets. A botnet is a network of infected IoT devices controlled by an attacker. Once compromised, these devices can be used to launch large-scale distributed denial of service attacks. Spoofing. Spoofing occurs when an attacker fakes the identity of a trust device to gain unauthorized access to the network. This can be done by cloning a device MAC or manipulating protocols like ARP. Sniffing involves the interception of unencrypted data as it travels between devices. Many IoT devices transmit sensitive information such as health data, location, or commands without the proper encryption and firmware tampering. This type of attack targets the firmware, the low-level software running on IoT devices. By modifying the firmware, attackers can insert backdoors, disable security features, or gain persistent access. Zero Trust architecture for IoT. The IoT environments, specifically these with thousands of distributed devices, Zero Trust is a critical model for ensuring secure operations. Its core principle is never trust and always verify. With Zero Trust, base are the less privileged, use microsegmentation, and the continuous monitoring. Some security standards and regulations that we have in IoT. We have ETSI that focus in consumer IoT, the NIST that focus in IoT capabilities, and ISO that these are reference architecture. The best practice that we could have in IoT is the secure by design. In the design phase, we define security requirements alongside functional ones, conduct a threat modeling to identify possible attack vectors early. In the development phase, enforce secure coding practice to avoid common programming flows like buffer overflows, injection. In the testing phase, we conduct the penetration testing to simulate attacks and evaluate the robustness of the system. And the deployment phase enables secure boot to ensure only trust firmware and software that are allowed. The future of IoT and 6G. We have quantum key distribution that quantum computing poses a serious threat to traditional encryption algorithms in response. Quantum key distribution offers ultra-secure communication by leveraging the principles of quantum mechanics. Blockchain technology introduced decentralization, transparency, and immutability into IoT environments, and self-healing system. As attacks grow more sophisticated, systems must become more autonomous in defense. Okay, key recommendations: the secure by design, automatic updates, and network segmentation, artificial intelligence monitoring with vision of devices and vast data flows. Manual oversight is no longer enough. And the last one, user education. Human error remains a major source of security incidents. We have to educate both users and administrators on best practice. And the conclusions, we have standard compliance adhering to established security standards, ensure a strong foundation, security innovation to stay ahead of evolving threats and innovation is essential. Explore advanced technologies like quantum key distribution, blockchain, or self-healing systems. Continuous monitoring, that real-time visibility is crucial in hyper-connected environments. Deploy artificial intelligence power monitoring tools to detect anomalies and predict potential threats. And again, user education. People are often the weakest link, but they can also be the first line of defense. Establish training programs that focus on strong password, update policies, and social engineering awareness. And my final words, security is not optional, it is essential. We must treat it as a foundation element, not as an afterthought. Prevention is always cheaper than recovery, and investing in security early helps avoid costly breaches and service disruptions. And collaboration is the key across the ecosystem. Thank you for your attention. If you would like to connect, feel free to scan the QR code or reach out via LinkedIn. You are mute, Pau.
Sorry. Thank you so much, Aaron, for your presentation. It was quickly, but but I think was okay and sorry for the delay, but was okay for the time. I'm so sorry. For the next time we will need to.
Yes, I'm going to share my presentation, that if you have any question, you could contact me by LinkedIn or my email.
Okay, exactly. Thank you so much. And sorry again. And okay, Aaron was our last speakers in this day. Over this course of these two sessions, we have seen how the technical advancement and ethical responsibility go hand in hand. We have explored a range of perspectives for the technical frameworks and federal learning to regulatory compliance and the unique demands of IoT within 6G ecosystem. We sincerely thanks to all of distinguished speakers for their insight and all of you for your engagement and commitment to shaping the future of secure, ethical, and inclusive communication technologies. I want to thank to UCD, to BUB University that was a hand with us for this event. We want to thank also to BART for be part of this event and for be a important key for this. I don't know, something you want to say, Bart?
Yeah, I just want to return the favor and thank you for the organization, because you always thank everybody and you always forget about yourself. So thanks, Paola. It was great, and especially this event was difficult to organize due to the timing constraints. We are 7 hours ahead of Ecuador, so I think it's best to meet up in person somewhere in the middle, or maybe in Ecuador or Europe the next time. So I just want to remind that the recordings of these presentations will be available on our official YouTube site. Also, there are a series of blog posts coming up, and we will be sharing contact details for the presenters. So if there are any follow-up questions or potential collaborations that you want to build, then that is one of the ways you can reach out to those presenters and everybody else. Finally, I think for those people that are not aware of the project, if you go to Ensure 6G, this is the ensure-6g.eu. Yeah, thanks, Paola. We have a lot of information there, a lot of blog posts coming up from our secondments, an introductory video, and you are welcome to visit. So Paola and the team at UDLA and all the presenters, thank you on behalf of the coordinator of the project.
Yeah, thank you to all of you. We are proud to be part of this project also, and also we are pleasure to collaborate in everything. Thank you so much to be here and to know to all of us, and we share with the researcher and them, and also with the speakers. Here is for the registration, please, for the second day. Aquí está para que se puedan registrar, por favor, del día número 2 en el forms. Yeah. Thank you so much, and see you the next time for the next event.
Thank you. See you soon. Bye bye.
Thank you. Bye bye. Gracias a todos por estar presentes el día de hoy.